By 2050, over 2/3 of the world's population will live in cities. That is roughly 6 billion people packed into urban environments that are already struggling to move the people they have right now. Traffic gridlock costs the American economy alone over $87 billion every single year in lost productivity. And the buses, trains, and subways we are relying on to solve that problem? Most of them are running on technology designed decades ago. Something has to give. In the next 10 minutes, you are going to discover exactly how public transportation is being completely reimagined from the ground up. We are talking autonomous buses, hyperloop systems, electric rail networks, and AI-powered routing that could make your daily commute almost unrecognizable within the next 15 years. But here is the thing nobody in mainstream media is telling you: the biggest revolution in public transportation might not come from the vehicles themselves. It might come from something far less obvious, and by the end of this video, you will understand exactly why that changes everything. To understand where public transportation is going, you first need to understand where it came from. The horse-drawn omnibus appeared in Paris in 1828, and within a few decades, cities across Europe and North America were building the foundations of what we now call public transit. The London Underground opened in 1863, running on steam-powered locomotives through tunnels beneath the city. New York's subway launched in 1904. These were engineering marvels of their era, and remarkably, the fundamental concept has barely changed in 120 years. You buy a ticket, you wait on a platform, you ride a fixed route, you get off. The innovation since then has largely been incremental. Diesel replaced steam, electric motors replaced diesel in many places, air conditioning was added, digital displays replaced paper schedules. But the core model? Virtually identical. The problem is that our cities have not stayed the same. Urban populations have exploded, travel patterns have fragmented, and the old hub-and-spoke transit model, where everyone goes downtown in the morning and back home in the evening, simply does not reflect how modern people actually live and move. Studies show that in American cities today, less than 20% of trips follow the traditional commuter pattern. People are traveling laterally across cities, at all hours, for an enormous variety of purposes. The rigid, fixed-route systems we built for the 20th century are fundamentally mismatched with 21st century urban life. That mismatch is exactly what the next generation of public transportation is being designed to fix. Electric vehicles have already begun transforming private transportation, but their impact on public transit could be even more dramatic. Electric buses are quietly becoming one of the most important infrastructure investments cities are making right now. Shenzhen, China, fully electrified its entire fleet of over 16,000 buses back in 2017, becoming the first major city in the world to accomplish that. The results have been extraordinary: annual reductions of hundreds of thousands of tons of carbon emissions, dramatically lower operating costs, and a measurable improvement in air quality across the city. Los Angeles, London, and Amsterdam are all following similar paths, with full electric bus fleets targeted within the next decade. But here is what nobody talks about when they cover electric buses. The real advantage is not just the zero tailpipe emissions. It is the data. Electric buses are fundamentally digital machines. They generate continuous streams of information about routes, passenger loads, energy consumption, and performance. That data feeds into AI systems that can optimize entire transit networks in real time in ways that were simply impossible with older mechanical fleets. The electrification of buses is not just an environmental story. It is the foundation for a completely new kind of intelligent transit network. Autonomous vehicles have dominated headlines for years in the context of private cars, but self-driving technology is actually advancing fastest in the public transit space. Several cities are already operating fully autonomous shuttle services with no safety driver on board. Navia and EasyMile have deployed driverless electric shuttles in locations across Europe, Asia, and North America. Singapore has been testing autonomous buses on public roads since 2019. The reason autonomous technology works better in transit first is simple: fixed routes are far easier to navigate than unpredictable private car trips. A self-driving bus that runs the same 3-mile loop every day has a much simpler technical challenge than a robotaxi trying to navigate any destination in a sprawling metropolis. The financial implications of autonomous transit are staggering. Driver compensation represents approximately 60% of a typical transit agency's operating budget. A fully autonomous bus network does not eliminate all those costs overnight. There are still maintenance workers, supervisors, and support staff, but it fundamentally restructures the cost model. McKinsey estimates that autonomous operation could reduce transit operating costs by 40% or more. Those savings could be reinvested in more frequent service, extended operating hours, or lower fares, making public transit dramatically more competitive with private car ownership for the first time in a generation. Now let us talk about the most futuristic piece of this puzzle, Hyperloop. In 2013, Elon Musk published a white paper describing a system of pods traveling through low-pressure tubes at speeds approaching 700 miles per hour. A decade later, the concept has moved from science fiction to active development. Virgin Hyperloop conducted the first human passenger test in 2020. Companies including Heart Hyperloop in Europe and Hyperloop TT are pursuing regulatory approval and route planning across multiple continents. The European Union has included Hyperloop in its long-term infrastructure investment framework. Critics remain skeptical about costs and timelines, and those concerns are legitimate. Early estimates for Hyperloop construction run between $40 and $100 million per mile, comparable to traditional high-speed rail. But here is the key insight: Hyperloop is not competing with buses and subways. It is competing with short-haul aviation. If Hyperloop can connect cities like San Francisco and Los Angeles, or Amsterdam and Paris, in under 30 minutes, it eliminates the need for hundreds of daily short-haul flights, drastically reducing aviation emissions while radically reshaping economic geography. The technology that will have the most immediate impact on your daily transit experience is not autonomous vehicles or Hyperloop, though. It is artificial intelligence applied to network management and passenger information. Cities like Helsinki have built what they call mobility as a service platforms, apps that integrate every form of transportation in the city, from buses and trains to bike sharing and ride-hailing, into a single seamless journey planner with one payment system. Google Maps has pointed in this direction for years, but Moz takes it further by actually coordinating the services in real time rather than just displaying them. Kansas City, Missouri deployed a free smart transit corridor with AI-optimized signal timing and real-time passenger tracking, and ridership increased by over 70% within 2 years. That number should stop you in your tracks: a 70% ridership increase without building a single new station or buying a single new vehicle, simply by making the existing system smarter and more accessible. What does all of this mean for the average commuter and for our cities as a whole? The implications are profound and layered. Cities that successfully build next-generation transit networks will see measurable improvements in air quality, reductions in traffic congestion, lower household transportation costs, and more equitable access to economic opportunity for lower-income residents who disproportionately depend on public transit. Studies consistently show that every dollar invested in public transportation generates approximately $5 in economic returns. As autonomous and electric technologies reduce operating costs, that ratio could improve even further. There is also a land use dimension that is genuinely underappreciated. Better transit reduces the pressure to build endless parking infrastructure, freeing up valuable urban land for housing, parks, and community space. Some urban economists estimate that American cities dedicate 30% or more of their downtown land area to parking. Better transit changes that equation completely. The future of public transportation is not a single technology or a single breakthrough moment. Before you go, if you learned something valuable today, hit that like button right now. Subscribe to AutoVision Daily for a brand new video every single day. We will see you in the next one.